I mentioned the qualifying test before. So this is the qualifying test that those contestants took. So they had a round one test, and about 4,000 people in Canada, the US, and the UK took that test. And if a person scores 8 or above, and there's no age, well, you can't be 35 and take it, but you can be in middle school or 6th grade, whatever, you can still take it. And if you score 8 or above, then you move on to the second round. So this is the second round test here. And because we don't want to take up too much of the school day for teachers or the students, then it has a 15-minute time limit. And almost everyone takes it online with Maple TA from the MapleSoft company. And so all those contestants you saw, they scored a 9 on this test in 15 minutes, which is pretty good as far as I'm concerned. And then I don't know if you can see at the bottom of the screen, that's the tiebreaker question. And so because we could break the tie by saying how much money you're willing to send the host of the game, but people got a little upset about that. So what we decided to do is have a question that the closest person to that answer, the correct answer, which was 287,000 something, I think, then would be the person that would, if there was a tie, would break the tie. And so a lot of people do score 9, in all 3 countries, which to me is amazing. So I want to congratulate all the contestants for doing that. And then these tests are online. There's the URL. So sometimes students like to practice. The teachers would like their students to practice. And so we have the tests from previous years there. And you have a version that doesn't have the answers, and then we have a version that has the answers. So we won't spoil it for you. You can just get this version of it if you're interested. All right, so this will be so the rules change a little in the finals. It doesn't change that I get the money. What changes is, do you have to reset it? Samuel. Yeah, you just hit the buzzer, right? Yeah, we don't need the signaling devices anymore. So hold it up and test it just so we make sure. And then remember when you do signal that I need to see it because I can't see it over the thing. So when you do hit it, just hold it up. And so what happens here is that because we think they would just keep getting the answers right forever, which is not terrible, but we have to eventually have a champion. It's the first person to get it correct who gets points in this round, in the finals. And if they both miss on their first guess then or attempt, then they get another chance at it, just as long as there aren't 1 or 2 answers left at the end. And there'll be 5 choices in this. And this is the finals, as you can see, or the finals. And so, Brian, you set to go? Okay, and Samuel, he looks like he's set to go. You all set? All right, and so you remember the rules. So you want to signal in with those buzzers, and then remember to hold it up so that I can see that you have signaled in. And sorry, you don't have to wait for me to read the whole answer. So once the question's on the screen, you can signal in, but make sure you hold it up. And then you need to, when I call on you, make sure you give me the answer immediately. All right, here we go. As a letter, yes, as a letter. Yeah, and handwritten in cursive would be very nice if you could do that. All right, so here we go. We'll let n be the smallest positive integer such that the difference between n and the number that results when n's digits are written in reverse is a non-zero multiple. Who's signaling? Hold up your thing, Samuel. I just want to see. Okay, what's your answer, Samuel? C. C? So you said C? C? Okay, good. All right, so I'll finish reading the question, and then you'll have 60 seconds once I'm done reading. And Samuel can still figure it out in case Brian's choice isn't right. When n's digits are written in reverse is a non-zero multiple of 7. What is the sum of the digits of n? Is it 6, 7, 8, which you might not choose, 9, or 10? Brian? D? Yeah, so it would be good maybe to turn on the mic so I can hear whenever. So D is correct. Nice going, Brian. That was quick. Usually I go over and tell them what's the right answer for the next one, and they'll see how many, whether they believe me or not. And then just like this, the last 2 games, we'll show the scores at the halfway point. So, and we go 1,000 times Fibonacci numbers here. So it's 1,000, 1,000, then 2,000, 2,000, and you can see what happens after that. We didn't start at 0, or we didn't go 2 1s in a row. All right, so here comes the second one. You're both eligible. Oh, you reset, Brian. And Samuel, yours is white there? Okay. Oh, yeah, right, there we go. A prime p such that, Brian, you signaled in, right? Okay. D, C. C, Marie-Sophie Germain? C is correct, yes, very good. Yes, Samuel. Samuel, why did you walk away?
Because I didn't click fast.
Well, I don't know. You were pretty close to fast enough. All right, and so, Brian, how did you get that so fast? You should turn on your mic.
I recognized that 2p plus 1 also being prime and 1p is prime is something called a Sophie Germain prime. And then I saw Sophie Germain, so then that was the answer. Yeah.
So yeah, exactly right. And so I hadn't noticed 2p plus 1 yet, because I was still reading a prime p, the third word there. So I think we'll find out a little bit more about her. I think. And then we have James Cannon.
G'day. Let me tell you a little about the work of Marie-Sophie Germain. She was a French physicist, philosopher, and mathematician who did great work in the theory of elasticity, in number theory, and the like. In fact, she lived at a time in Europe where women were actively discouraged from thinking scientific thoughts. She'd never be able to go to university. She'd never have a professorial role. But she persevered nonetheless. In fact, she wrote to the likes of Legendre, Gauss, Lagrange, and actually developed a correspondence with these folks who actually supported her work and encouraged her. Good for them. And she developed her international reputation that way. Grand. So let me tell you about her work in mathematics in particular, because we best remember her for her work in number theory in relation to Fermat's last theorem. Now recall, Fermat's last theorem asks, are there any integer solutions, non-zero integer solutions to the equation a to the n plus b to the n equals c to the n for different powers n? Now for n equals 2, easy peasy. We know about those. They're called Pythagorean triples. It's really the higher powers, n equals 3, n equals 4, n equals 5, n equals 6, and so on, that people were wondering about. In fact, people wondered about this for decades. Decades. Thank you, Fermat. It was such a tough problem, it was driving people batty. But Sophie Germain made significant progress on this problem with her work in number theory. Grand. So let me tell you what that was. So people noticed, for starters, that composite powers, don't have to worry about those. If I could prove, for example, there were no integer solutions to, say, the 5th powers, this prime 5, then there'll be no solutions to the 15th powers as well. So actually, it's good to just focus on prime powers. Great. Cut down our work a little bit. In fact, odd prime powers, because n equals 2, done. We know there are solutions to those. So the question is, are there any integer solutions to a to the p plus b to the p equals c to the p for different odd primes? Now people at the time realized, okay, it's actually helpful to split this problem into 2 cases. Maybe some of these numbers a, b, and c are multiples of p themselves, or maybe they aren't. Case 1, let's assume none of these are actually a multiple of p. Case 2, let's assume that maybe perhaps one of these is a multiple of p. All right, turns out that second case is particularly tough. The first case was also very tough, but that's the one that Sophie Germain managed to crack in a significant way, because she managed to prove there are no integer solutions to a to the p plus b to the p plus c to the p, these none being a multiple of p themselves, for all the primes less than 100. Wow. In fact, her work actually went a bit higher than that. She didn't realize she'd go beyond 100, but that is significant. She solved a whole class of problems for the type 1 version of Fermat's last theorem. Mind-blowing. In fact, we honor her work today because that was truly significant by giving a class of primes, these primes, a name. We call them Germain primes today. These are the primes of the property that if you double them and add 1, they remain prime. So double 3 plus 1 is 7, prime. Double 5 plus add 1 is 11, prime. Oh, there it is, and so on. Great. These turned out to be significant for how she tackled her problem here. Now, apart from having fun today, I have some optional homework for you. Can you tell me whether this list of Germain primes goes on forever, or whether it eventually stops? Because if you can solve that particular problem, methinks you're going to be a world-class mathematician. All right, thanks so much.
All right, so that was James Tanton, who was here earlier at 10 o'clock, and I think his official title is MAA Mathematician at Large. I can't remember for sure, and explaining about Marie-Sophie Germain. And you guys have been itching to get back to the next question, so here we go. Here comes question 3. 3 strains of bacteria exhibit exponential growth. Strain A doubles in population every 2 hours. Strain B triples in population every 3 hours, and strain C quadruples in population every 4 hours? Go ahead, Brian.
B.
Yes, Samuel?
I clicked before, but it didn't work.
You should have been reset. How do you know you flipped before?
Because I did it like 3 seconds before.
It's better if you leave it on the table.
Oh, did you hold it up in the air, Samuel?
Yeah.
Oh. Sorry, Samuel. That is the right answer, yeah. Yeah. So we have to give it to Brian. Samuel, it's good to keep it down and then lift it up whenever you've registered. Brian, you want to tell us how you got that?
So in each hour, A goes up by a factor of the square root of 2, B goes up by a factor of the cube root of 3, and C goes up by a factor of the fourth root of 4. And we note that the square root of 2 and the fourth root of 4 are equal, and then the cube root of 3 is greater than the square root of 2. So then the cube root of 3, which is string B, is faster than A and C, which are square root of 2 and fourth root of 4, are the same and slower.
All right, thank you, Brian. Samuel, one thing, you could leave your microphone on. That might be one thing you don't have to worry about. So you can turn it on now if you want. And then don't let the 2,000 upset you, because there's still a lot of points left, okay? Okay. All right, so here comes question 4, also for 2,000 points. And everything's reset?
Yep.
Okay. It takes 5 lumberjacks 5 minutes to cut 5 equal-sized logs into 5 equal-sized pieces each. How long will it take 10 lumberjacks working at the same rate to cut 10 of the same size logs into 10 pieces each? Is it 5 minutes, 8 minutes, 10 minutes, 11 1/4 minutes, or 20 minutes? Is that you, Samuel?
Yeah.
And your answer?
D.
D, 11 1/4?
Yeah.
That is correct. Nice going, Samuel. Very good. So, Samuel, why isn't it 10?
Well, it's a trick because you have to cut it into four pieces for each of the 5, but only 9 for each of the 10. So you're taking 9/4 of 5.
That's exactly right. So that's an easy trap to fall into, you might say, and you didn't fall into it at all. And that's exactly right. And so then the rest of the figuring was easy once you figured out the pieces. Were you thrown for a loop at all about the pieces to start with, or?
No, I've fallen for that trick before.
Okay, all right, okay. All right, well, very good for you, Samuel. All right, so now we'll see the score. And then, so they're 2,000 points apart. So Brian with 4,000 and Samuel with 2,000. And there's still 4 more questions. And so the next two will be worth 3,000 points. And everything, so the red means reset. Okay. Here we go. You're presented with 5 doors, and you get to open 2 of them. Behind one door is a $1,000 prize, and behind another is a $500 prize. The rest have nothing. If you choose 2 doors at random, Samuel, is that you or Brian?
Me.
Okay.
D.
D, 7/10? Did you say D?
D. D.
D as in dog, I think. 7/10 as in dog is right. All right. It turns out the money doesn't matter. At one point we were going to ask the expected value, but we didn't. So Samuel, how'd you get that so fast?
I just did complementary counting.
Uh-huh. And you want to give us the details?
Okay, so there are, the complement of that is, so there are 2 of them that have the prizes, and then there are 3 of them that don't. So you could just pick 2 of the 3, and there are 3 choose 2 ways to do that, and then that's the complement of what you want. So you do 1 minus 3 over 5 choose 2, which is 10, so that's 7/10.
All right, that's exactly right. Very good. Nice going. Thanks for the explanation, Samuel. So here we go with question 6. So there are 8 questions total in the finals, just like in the semi. Oh, I forgot to say the score. So Samuel now is in first place. It's, most of the time the finals aren't so close. Right now it's very close. Samuel with 5,000 and Brian with 4,000. Very tight game. Here comes question 6. We'll let h of n be 1 plus a half plus a third plus dot, 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 up to 1 over n. So a partial sum of the harmonic series. Exactly one of the integers below has the property that h of n is strictly between, Samuel, is that you?
C.
C41? C41 is right. Samuel? Samuel, do you know the trick about the harmonic series too, like you
Yeah.
did with lumberjacks, or?
It's roughly tilde, natural log of n minus the Euler-Mascheroni constant.
And so when you knowing that, that's good to know that. And then how did you get to 41 so quickly?
I just approximated powers of e.
All right, okay, all right, there you go. That's very good. It's good to know that in the first place, but then be able to use it so quickly is also very good. It's okay to clap for Samuel if you want to. Don't, just because I'm talking. All right. Here, oh, and now we'll see the score. I almost forgot. Samuel with 8,000 now and Brian with 4,000. So 2 questions left, each worth 5,000. The line between -1, 0 and 1, 6/7, so that's x coordinate 1, y coordinate 6/7, intersects the circle x squared plus y squared equals 1 in a point a over c, b over c, not on the x-axis, where each coordinate is in lowest terms. What is a plus b plus c? Is it 12, 50, 59, 70, or 119? Brian, is that you?
A.
A12? That's incorrect. So Samuel, you have 60 seconds. Brian, you can, at this point we don't let them guess again, right? Because it's the last 2 questions. Right. Right. Samuel?
C.
C59? Incorrect. It was D70. I think, can't remember what it was a 29, I can't remember what the numbers there. I think it seemed like there was a 29 there, but I can't remember for sure. Okay, so the score will say that, so you all don't have the rules, but in the rules, in the last 2 questions, each gets just at most 1 chance at it. All right, so it wasn't, we just decided that we're running out of time or anything like that. That's what's in the rules, and so it looks like it may come down to the last question. We'll see what the score is. So Samuel has 8,000, Brian has 4,000. Here's the last question for 5,000 points. The product 1 factorial times 2
B.
B?
B.
B is correct. All right, Samuel, do you want to tell us about that one? So get close to the microphone so they can hear you, because they're very interested in how you get that so quickly.
There's a story behind this one.
There is.
It's
Well, let's hear it.
A friend gave me a similar problem.
That person's a closer friend now, probably.
So it was basically, I did it just by looking at the powers of, the number nearby. So basically, if you take out 1010 factorial, then you're basically taking out, how do I explain it?
Is it powers of 2 or?
No, you were left with an even number of all the primes greater than it, but then basically there's some more work that goes into it. It takes a little while to prove. There are no other numbers that have this property. So
And you need each of the prime powers to be an even number,
yeah.
with once the right one's removed.
Yeah, and then you can check numbers nearby to make sure that it will eventually become odd for one of them. So
So, Samuel, we're very happy that that 2,000 point thing didn't ruin the score for you, or ruin your first place, and very happy for you that you won. As an 8th grader, you know, that's pretty good. It's pretty good for anyone to win, but for an 8th grader, that's really good. Brian, do you want to come over here and pose? So you may have seen it. Don't forget the Porter Lectures at 3, and we'll do an award ceremony here for Brian and Samuel, and also the people who won the Maple software. That's going to be, in fact, let's start it. That's going to be hosted by Catherine Roberts, who's the AMS Executive Director, and she's right here, and she has many dignitaries to introduce. And I don't know if she's going to make a hand-waving joke herself, but what I hope. So here's Catherine Roberts. You got a finger there if you can. So there's the names. Can you read it there?
Yep. All right. Good afternoon, everyone. Thanks so much for coming to this event and for coming to Mathematicon. And I hope many of you will be staying with us for the Porter Lecture to learn about mathematics and its role in helping us understand gerrymandering. That'll be at the ballroom right next door, starting at 3 o'clock. So we'll quickly do this award ceremony. I have some dignitaries to bring up to the stage to help me out. The first is our immediate past president, a professor at Duke University, Professor Robert Bryant. The second is our current president of the American Mathematical Society, professor at UC Berkeley, and that is Professor Ken Ribbett. And finally, we have quite a rare treat with us. There is one member of Congress here in the United States who has earned his PhD in mathematics, and he's with us here today. We have Congressman Jerry McNerney. I'm going to invite Representative McNerney to just say a quick few words, and then we'll give out the prizes.
Well, thank you, Catherine. You know, I got here a little bit late, but it was sure a pleasure to see this contest, to see the young folks that are enthusiastic, and see the audience that cares so much about them. And you know, they don't get here on their own. They're very bright and they work hard, and you can see how quick they are, but they got something behind them. They got parents that support them. They got family. They got good schools. Are there any family members here of the 12 contestants? You please stand up and just be recognized for your support of these young men and women. I bet you're even prouder of them than we are. So we're going to go ahead and conclude the ceremony, but thanks for coming. Thanks for your support. Thanks for you all for sticking your necks out. I know what it's like to stick your neck out and sometimes not win. So good work, and I hope you continue to have your enthusiasm for mathematics. It's a great field, and you'll go a long ways with it.
Mike, do you want me to start with the Maple 2017? Okay, so earning the Maple 2017 prizes, we have 2 people. We have Andrew Lee and Justin Yu. Oh, they can help, and that's what they're here to help. They're here to help.
All 3 of you can get there.
And pose for some pictures. Yep.
Yeah, see, it's not easy to come forward.
All right, thank you. All right. And our second place trophy goes to Brian Liu. Come forward. And the first place winner for Who Wants to Be a Mathematician here at the Joint Mathematics Meeting, the American Mathematical Society is pleased to present Sam Goodman.
Very good, Catherine. Sorry to spring it on you.
No, no, it's fine.
Probably are.
All right, thank you. Thank you very much, and please join us next door for the next lecture. There is a survey here. If you care to fill it out, we'd really appreciate it.